My name is Ganesham Pramod Patil.
My name is Aditya Ashok Sapte.
Our topic name is
IoT based low cost ECG machine using UV platform.
under the guidance of Professor Shilpa Joshi ma'am.
We are from B8 batch under the coordination of Deepa Bhandare ma'am.
Now we will briefly go through our PPT. Our project title is IoT based low cost ECG and heart monitoring system with ESP32 and UV platform. My name is Ganesham Pramod Patil and my colleague name is Aditya Ashok Sapte. Under the guidance, we performing the project under the guidance of Professor Shilpa Joshi ma'am. Following points are covered in our PPT. First, propose a project title. Second, aim and objective. Third, literature survey and review. Fourth, methodology. Fifth, block diagram. And sixth is about ESP32 model which we have used in our hardware. UV platform and conclusion. Now, the main objective of our project is remote health monitoring, then cost efficiency and real-time data collection through the UV software. Now the literature survey. We take three IEEE based projects. First is a low cost wearable ECG monitoring system and algorithm for identifying atrial fibrillation. This paper is published in 2019. This paper article contains the project discussion, the development of low cost wearable ECG monitoring system for detecting atrial fibrillation, highlighting the importance of cost effectiveness and remote monitoring. Second paper is the second paper is IoT based real time remote health monitoring system, and the paper is published in 2020. The paper presents an IoT based remote health monitoring system that includes ECG monitoring, data transmission and cloud based analytics, showcasing the potential of IoT in healthcare. The third paper is about wireless ECG monitoring and alarming system for patients mobility. This paper is published in 2018. This research paper contains explores the ECG development of wireless ECG monitoring and alarming system, showcasing the potential for mobility and real-time data alertness. Now the methodology. So we have to first gather the necessary components, then design a circuit, then develop the firmware, implement the data transmission, integrate with UV test and validate and check the output waveform. Now this is the circuit diagram of our project. We connected the ECG electrodes to the human body, and in this circuit we have used ESP32 module microcontroller, then ESP sensor AD8232 module. Now this is the block diagram of our project. First of all, we have connected the ESP Room 32 microcontroller to our PC, and the microcontroller is connected to AD8232 ECG sensor, and the ECG sensor is connected to human body with the help of 3 ECG electrodes, lead electrodes. The 5 volt DC power supply is given to the AD8232 module, and microcontroller is connected to PC, which is the 3.3 volt supply is given. Now the ESP Room 32 microcontroller and AD8232 ECG sensor is connected via output is connected to VP pin, then LO minus is connected to D35 pin, and LO plus is connected to D34 pin. The following PPT is presented by my colleague Aditya Ashok Sapte.
Hello, myself Aditya Sapte. In this PPT, in this slide, we are going to see why we have used ESP32 in our project. First point, it is low cost. Second, low power system on a cheap microcontroller with integrated Wi-Fi module and dual mode Bluetooth. It has two module. Which is one is Wi-Fi based and the second is Bluetooth based. Then third point, low noise receive amplifier. Fourth, power use is very less, up to 3.3 volt DC. In this slide, we are going to see about UV platform. UV is an IoT platform which innovates and industrials to prototype and scale IoT project to production. Second, use the UV platform to send data to the cloud from any internet enabled device. You can then configure. Talking briefly about UV platform, when we connect 3 electrodes to the human body and we have used ESP32 microcontroller. The microcontroller is a Wi-Fi based microcontroller that sends the data to the UV platform through wireless technology, and through UV platform we can manage or we can see the graph of a patient online from anywhere. The advantages of ECG machine are it helped in diagnosis heart condition by recording the electrical activities. It is convenience and cost effectiveness. increase mobility, reduce anxiety. This is the output waveform of our hardware module. As the output waveform can be explained by this slide. The first of all, the point P is a ECG at atrial contraction. Second, QRS is a complex representation of complete depolarization of ventricles. The point ST shows depolarization of ventricles. The point QST shows complete depolarization and repolarization of the ventricles. This is the graph of our hardware module and the original graph of the ECG machine which we have seen at the hospital. The upper one is the waveform of the hospital ECG machine and the lower one is the waveform of our ECG hardware. Following are the reference point from where we get the information about our project.
Now we will connect the ECG electrodes to the human body. So we have ECG gel. So we have to put it on ECG electrodes. Just a drop could be like that. We have connect the yellow electrode to the left side of the heart body. The second one, which we have to connect to the right side of the body. And the green one is connected to the lower part of the body. So as we can see, we have connected the ECG electrodes to the human body. So as we connected it, so we can proceed to the software connectivity.
Coming to the programming part, as you can see, we have opened the UB.dot platform from where you can access the graph. First, we have to add the variable from the dashboard. We have to select line chat. Then we have to add the variable which we can further be used in the programming part. Thus, you can see we have added a variable. Now coming to the programming parts, we have done the programming on Arduino Uno. First, you can see we have included the library pub/sub client. Then we have included 1 2 3 libraries. Then we have to connect it to our mobile hotspot. We have given the Wi-Fi name and Wi-Fi password. Then the token is taken from the UB.dot platform. As you can see from here, we have taken the token and copy paste it in our programming part. Then the variable name and device name we have firstly given on the UB.dot platform, and this is the program that is used to run the software. This is the output waveform. Thus, the waveform has been achieved and both hardware and software both are in the working condition and the objective and aim is fulfilled.
So we would like to thank Professor Shilpa Joshi ma'am and special gratitude towards Dr. Aditya Rajput sir.
Thank you.
Thank you.